Awesome. Okay, let's get started. Let's see. All right. So welcome to DSA series arrays. Today is Monday, November 7th. Like I said before, I'm going to post this in the chat. All of this material, a lot of it I've read, except for the Ruby code that I am coding in Ruby, by the way. So we'll circle back on that in a second. This is the Pluralsight class that I'm kind of following the curriculum of what he does. His name is Robert Horvick, and I think he's just really great. And I thought, why not share this and do this together as something we can do at Women Who Code and share the love. All right, so welcome to this class. Today's agenda, icebreaker. We're going to go through array, properties, and code, and actually big O, which I left off here. And then we'll do questions. All right. So just a few things that, we need to discuss before we get into our course. So our mission at Women Who Code is inspiring women to excel in technology careers. Our vision, a world where diverse women are better represented as engineers and tech leaders. Our code of conduct. Women Who Code is an inclusive community. It's dedicated to providing an empowering experience for everyone who participates in or supports our community, regardless of gender, gender identity and expression, sexual orientation, ability, physical appearance, body size, race, ethnicity, age, religion, socioeconomic status, caste, creed, political affiliation, or preferred programming languages. Our events are intended to inspire women to excel in technology careers, and anyone who is there for this purpose is welcome. We do not tolerate harassment and members of any form. Our code of conduct applies to all events and online communities. If you'd like to learn more, you can read the full version and access our code of conduct, which I can put in our chat. All right, let's get started. And if I'm moving too fast, please do let me know. All right. So let's go ahead and jump in. Thank you guys for joining me. We're starting with arrays. The first thing I will say tonight, I will be coding in Ruby. So I suggest and would love for anyone who also knows the methods that I'm going to go over tonight, if you want to post them in the chat in your own language, like JavaScript has very similar methods, or any other methods that you see when I'm writing in Ruby, please share them in the chat so we can be inclusive of all languages. I just feel most comfortable with Ruby. My stack is backend Ruby, front-end JavaScript, but I, in my boot camp, learned Ruby the most, I feel like, personally. And so that's what I'm going to code in, and that's what I choose to code in for my interviews. And I would suggest going into interviews to always choose the language that you are most comfortable in. All right, now let's get started. Why arrays? So arrays allow for us to store items in our applications. Instead of setting a variable to equal a certain data X number of times. So like if we had in JavaScript, let name equal Jesse, and we repeat this, let name equal, Julia, let name equal Anna. Instead of doing this so many times, we can store it in an array. An array can contain multiple instances of a type. Arrays use numeric indexing, so they begin with 0. We can access individual items within an array. Arrays are static or dynamic in size, but they are a fixed size once they are created. All right, so let's go to the next slide. All right, we're going to go over a few things right now, like a few ways to manipulate an array. We're going to create, access, and manipulate an array. First, let's review a few terms. So brackets are the telltale sign of an array, right? We know that we have an array when we see brackets. What's an index? An index is where the data or value is stored at that index, okay? And again, we start with 0. Types, an array can store multiple data types, symbols, strings, integers. An array index 0 means the first value in an array. Array index 1 is the second value of an array. Access, we can access, the great news is that we can access data at any index. And it's pretty easy to access data at any index. Assignment, we can set an index to a value. Insertion, add a value to the beginning, end, or at a specific index. Deletion, delete a value at the beginning or at the end or at a specific index. And iteration is looping through an array in number of times or however many times we need. All right, any questions? You guys good? Am I going too fast, too slow? Cool. All right, let's go ahead and jump into some code, not my word code. Let me pull up this lesson. Okay, great. So this is really basic. I, want to just go over, what it means or what it looks like to create. And we're just going to go through and hopefully take about, 10 minutes, maybe more, going over creating an array, accessing an array, assigning an array value. We will do removing, adding, and then we'll do loops. And then after that, if you guys have any questions, thank you, Corey. If you guys have any questions, I'm a bit rusty. It's been a while since we posted. If you have any questions, we are going to move over to Big O notation. All right, so let's go ahead and look at the way an array can be created. In Ruby, this is a pretty nice way of creating an array when it comes to strings. And you use a percentage sign and a lowercase w because it means the strings or the values inside of the brackets will not contain interpolation. If you use a percentage sign with a capital W, it's going to mean that it can contain interpolation. This is for strings. Also, another way is just to assign variables within the brackets, like we stated before. So if we were to put this in our console, we have a nice little array here, right, of names. And the output looks the same, right? I don't know if anyone wants to add in how they create an array from JavaScript. I think you can do like an array from anything, if anyone wants to post that, but if not, that's okay too. So we can access our array. Yeah, that works. Thanks, Catherine. We can access our array, right?
Jesse, before you move on, could you explain what interpolation means?
Yeah, so interpolation is whenever we are doing something like this, where in Ruby it looks like this, okay? But we want to maybe have a value. So like say if we had like in Ruby, it would just be name equals like Jesse, right? Say I want to add name here, but and typically it's for dynamic programming. It can be for whatever you want, but now I can change name. And if I want to put name, right? Like if I wanted to print out name, let's see if this works. It's going to print Jesse. But the cool part about this is inside of this string, says hello, right? So this is a variable, right? Which is set here, but I am interpolating it within this string, right? So this name could be like change into, we'll just use Anna, and it will have the same effect, right? But I don't have to change it each time, right? Thank you, Christine. So Christine showed us a way to do that in JavaScript, which is very similar to Ruby. And it's a great way to, yeah, dynamically program, so you can change, but you can also print out strings. But you can have a part of the string is like static, but the variable can change. Does that make sense? All right. So in this case, we're not really going to get into that too much tonight, but that's what that means. So if we wanted to access an array, some of the easiest way to do this, actually, let me put names again, just to make sure I've declared this. If we want to access the index at 0, the easiest way to do this is just to do names, bracket, and then the index that you want to reference. So here you can see we're accessing 0, which is our first index, which is foo, right? If we want to access the second index, then yes, thank you, Del. This would be the second index, right? Which is 1, because we start at 0. And you can see that our console gives us bar, okay? If we wanted to do the third index, we can do puts names 2. So this is pretty nifty. It's really nice, super easy. We can just say, hey, at names, at this index, give me that value. All right? Are any questions? Do you guys have any questions? All right. So now we can go through simple things like, let's just check the length of the array. In Ruby, I'm not sure, actually, I do think they have something in JavaScript, but we can get the length of the array just by adding .length on the name of, like, this is my array's name, right? So we'll do names.length. If we want to access the last element of the array, we can do -1, okay? So this is Ruby. I'm not sure if you can do that in JavaScript, but in Ruby, you can access the last item by putting in -1. All right, names.length comes into, okay, awesome. Thanks, Patricia. Names.length comes into, yeah, Python and Ruby are actually very similar. And I think Perl is very similar to Ruby as well. But I think the closest that I've seen is Python. But JavaScript really has a lot of similarities to Ruby. So the syntax is just a bit different because of the brackets, the parentheses and whatnot. Okay, so names.length is nifty, especially for like JavaScript users. When you're iterating through for loops, you might want to do the length of the array, right? All right, so let's assign an index, let's assign a value to an index. So at this point right now, right, let me just clear my console. At this point, we have names. Okay, so we can see in index 1, we have bar. And what we can do is say we want to override this. Yes. Yeah, that's what I thought. Yeah. Good mention on this. So let's say we want to like add a value to an index of an array. I want to put it in the second list, in the second, as the second item in the array. So I'm just going to say, hey, names in this bracket at this index, I want to put hello. You can see here when I call names, hello has now overridden what we had before, which was bar, right? But our length is still the same, right? All right. However, if we wanted to do names 3, which is an index we don't have, remember we only have 0, 1, 2. Let's say names 3 equals world. We can put names. Awesome. World is now in our array. Now, if we do names.length, we have 4. Cool. Any questions? Thoughts? Okay, you guys good? All right. All right, cool. So let's do a little more play around. Yeah, we can. And I think that's what's kind of cool about arrays, like, and a lot of data structures are this way. Where we can, like, if you see array 3, we can have a string, I can have a number, and I can have, a string, and it's totally cool. Right? So I'm going to use this example of an array for right now, and we're going to do a few like fun things to this. In Ruby, we have a cool little sorting method. I don't know if JavaScript has this or Python, but we can do array dot sort, right? All right. Awesome. Beautiful. All right, cool. But wait, is that going to save our sorted array? No, it doesn't. And this is important to know. And something I learned really when working on, oh, good call, Daya. I didn't know that. That's interesting. Thank you for sharing that. In this example, when we don't use a bang in Ruby, which we call a bang an exclamation point, when we don't use it, it doesn't save the array, sorted array. But if we use a bang, and this is for any method, like if we want to do reverse or unique or anything where we're changing the array, and these are built-in methods with Ruby, if we use that, it will save the array as a new array, okay? So there's a nifty little method called array.sort. This is another one where we can call array.reverse, right? So array.reverse, if we don't use the bang, it's not going to save it. If we use the bang, it saves it for us. If we can always add it, we can save it by putting it into a new variable like this. But a cool way to kind of make your code a little shorter is just by using this bang at the end. All right, so these are two cool, like fun things to play with. All right, so we have removing an array. So we're going to go through these. So pop, I like to think of just like some things like popping out. So pop is actually a very useful method, and we're going to see this in other data types, not just within an array, okay? But they're kind of different when we get to queues and stacks, but we'll talk about it when we get there. So if we want to do array.pop2, it's going to give us our last two values, okay? So our array is reversed and 0 and 1, and it gives us 0 and 1, 1 and 0. Now, the cool thing is that if we wanted to store these in a variable, we could, and then we could call last two values and then play with those two values, right? Like, so there's a lot of stuff that this can like help us with when we're wanting to manipulate data. But when we go and we check our array, we notice that those two values are no longer within our array, right? So pop is pretty useful for removing the last values or the value that's at the end of the array, okay? This is array.last, which just grabs. I just wanted to show you guys these because they can be useful when just trying to grab data and, working with an array. At this point, we have 5, 3 as our last two vowels. Well, dot last doesn't do anything. It just gives me those last two values, right? And then if I wanted to do like the first two values, we could do array.first2, right? This doesn't change the array at all. It just helps me grab those, and then I can, play with them however I see fit. So if we want to do these, we have our first two values, but our array is still intact, okay? Now, another cool one is shift, which does the exact same thing as pop, where we're going to pop two values But at this point, we're going to remove them from the beginning of the array. All right. So now our array looks like this. I think shift, I don't know, I still struggle with these two. Shift and unshift are like, I'm just never going to get them right. I've been working in Ruby for a while and I still have to like double check. But I guess I try to think of it as like shift. Okay, thanks, Larry. Pops from the front. Yeah, and I think it moves. When I think of shift, I think it moves the array forward, right? Like that's what I try to remember, but I always get confused. But it shifts the array. So like the items that you've removed, everything shifts forward, right? Another cool method in Ruby is array.delete. This is kind of a cool one because we can actually access and we can say, hey, we want to delete this value. So if I call array.delete 3, I'm passing in 3, and then I call array, our 3 is gone, right? So that's really awesome. The only thing about delete is that you need to, oh, okay, I like that, Janice. Unshift is the longer word and it adds to it. Okay, cool. That's great. Thank you. This is all helping me too, teaching helps you, I guess, become an expert. So we'll be experts together. So thank you, Janice. But yeah, so the only thing about delete, like if you want to use this in like leak code or in your algos, you have to like find that value first, but it's pretty useful. All right. Any questions? So quickly, so far, we've gone over creating an array, accessing an index, a value at an index, the length, assigning an index to a value, adding and deleting and accessing, okay? Sorting. Oh, no, I'm sorry, excuse me. Sorting, we've gone through removing and deleting so far. So right now we're going to move to adding an array. All right, adding to an array. I'm using different examples here. All right, so now we have A, B, C, D is our array. So yes, this is going to add to the beginning of an array. Thank you, Janice. It's the longer word and it adds to it. Awesome, I like that. I'm going to add Z to the beginning and voila. Our beautiful array is returned for us. We now have Z, A, B, C, D. Push is very nifty as well. We want to add to the end of an array. We are going to use push. Array, push. You can also add at any index. Like if you want to add at a certain index, you can. But if you're not specifying, it's going to go to the end of it there, at the end of the array, right? So array 2 now looks like this. And in Ruby, we have this little shovel, I guess is what we call it. So the little shovels add whatever you want into the end of the array. All right. And we could do also something, we could also add arrays together using concat, okay? Awesome. All right, so we're gonna keep moving forward. And these are not like this isn't that in depth of finding a value, because a lot of the more, I would say, like deeper finding a value comes through like iteration. And I don't know that I have that much time tonight to go through, complex loops or finding, but I have a few. But right now, these are a few built-in methods where this can help us find, in this case, if we have array 3 and we want to find the index of the number 3, it will return our index, which is 3. And this is helpful if we need to like manipulate arrays and change arrays at a certain index, right? Another nifty Ruby built-in method is include. Does it include A? Yes, true. All right, awesome. So I'm going to go over a few other things and then we're going to jump into loops. Does that sound good, guys? Yeah. Does anyone have any questions? Is everything good so far? Like pretty normal stuff? All right. Cool. All right. So here we have array 4. And it's important that you note that I have duplicates. And I also, yeah, I can, oh, actually, Kristen, so Kristen asked if this code can be available. Last time I tried to send this out, I don't think I will be able to like send out attachments, but if you join, it's not in a code pin, but if you join the Slack group, which I can add again, I can send it to you guys. Otherwise, I don't know that I can send out attachments. I tried last time. And I don't have it in like a repo actually. But yeah, join the Slack. And then if you want to Slack me, and I will send it to you. Sorry, I should probably make a better, yeah, sure, Larry. All right, so yeah, it is a little confusing. So let's say, okay, so here's array 3, right? This is array 3. Like say if we wanted to find dot index and we wanted to find D, it's going to give us the index of D. No worries, Kristen. Or if you want to do A in this case, I think you asked for A, it's 0. Does that make sense? And I think in JavaScript, it's index of. Okay. Let me see. So let's see. Yeah, exactly. Thank you, Del. Yeah, no, let's see. I think it might be nil. Yeah. In Ruby, Larry. So Larry asked, sorry guys, I'm just kind of reading the comments and kind of coding with you. So Larry asked if it doesn't, I think in JavaScript it might be. I think it also depends on the I think it might be -1 if it's JavaScript, but it depends on the language. But for Ruby, if it doesn't find the element within the array, it just returns nil. Okay, Del, thank you. All right. All right, cool, cool, cool. So many, everyone wants to learn. I love it. All right, cool. So going back to this array, which we have a nil and we have a duplicate. I like compact because it's going to take out those nil values for us. Thank you, compact. Then we can call unique, which will remove our unique values for us. 1, 2, 3, 4. Awesome, very clean. So this might be useful when you're like working and someone is like, you know, submitting, you have multiple objects in your database where you have multiple submissions and you need to remove those and you only want to save the unique value, right? All right, cool. Now we're going to go into loops and we're just going to use this, which is foobar. All right. So, well, actually, no, yeah. So for for loops. Okay, so this is where if anyone in JavaScript wants to put the for loop in JavaScript, I would be so grateful. I guess I could write it out really quickly. But I really actually don't have JavaScript committed to memory at this point in time. So if anyone wants to add that syntax, I think it's like for, and then in parentheses, and you need to do like let I, right? Yes, thank you. Awesome. Thanks, Anna. So in Ruby, it's a little more like simple. We just say for name and names, right? It can get a bit more complex. If you want to do like certain things like up to, there's a few different ways to play around with iterating and loops. But oh, okay, awesome. Yeah, that's great. Thank you guys so much. I love it. Christine, wonderful. All right, so yes, and actually, Dell, I love for each. I don't know. I'm just like a each for each. I like each, but yeah, awesome. Yes, so Anna gave us some JavaScript information with which goes over for in, for of, while, and do while. I'm not going to get into whiles today, but I'm going to do fors, which we're doing now, right? So we have names and we have foo, bar, baz. And essentially this all does the same thing. We're going to take in an array and we're going to say for the length of the array, which JavaScript does, right? Just going over for, right? Right. Just going over each item of the length of the array. You can make it more complex if you want. But for a basic iteration, it looks something like this. And in this case, what I do is for name and names, I'm saying puts name. So for name and names, so in each name at each index, it's going to iterate 3 times, right? Because we have a length of 3. And it's going to print out that index, foo, bar, baz. All right. So now what I typically use is each. And this is a different syntax for each because sorry, Yoshi's being a little weird. So the important thing for each, and I'm not sure if it does this in JavaScript, but it returns for each, it's going to return the array, right? So at this point, I'm asking array.each, the brackets, this first bracket is do, this second bracket is end. It's just a clean, simpler way of writing it. Array.each, I puts I, right? So for each index, I want to print it out. Print is like console log in JS, okay? Okay. For each, Yao says is undefined in JavaScript. Right, exactly, Yao, thank you. So at this point, I'm using each really just to play around with the data. I can save it to another value. You know, like maybe inside of it, I want to say like name equals I or number equals I, and then I could print out I later, right? But it wouldn't really be useful because it's not storing. I'd have to declare an array like numbers equal, and then I would just print, you know, loop them through and put them in this. But it's not very helpful for this because like Yao said, we can use map, which I'm going to show you in a bit. All right, Yoshi, come here. Sorry, guys, I apologize. So in this case, always remember that each returns the original array, but it's useful if you want to play with data within the each method, okay? In this case, it just adds, or it just, so if I want to do puts I plus 10 in my array.each method, I'm going to put out each array, each item, which I stands for item or index, and I'm going to add it plus 10, right? So 11, 13, 16. All right, awesome. Here's interpolation, right? So this is a great case of it where I didn't really want to, I don't want to change the value, but I wanted to show you guys what this method does. So in Ruby, we have something that's pretty nifty, which lets us do each with index. So I'm going to pass in the value and I'm going to pass in I as my arguments, right? And I'm going to print this out. And here you can see each time it goes through. So this is the first time that it's run, right? So what we're going to do is the value is 1, the index is 0. Here, my value is 3, the index is 1. And this is useful sometimes when I'm like debugging and I'm playing with LeetCode and I'm really trying to see, what is my data doing within this loop, right? All right. Any questions about that, you guys? I'm kind of, going a little fast. I probably need to pick it up a bit. There's a few other good things. Dell says it also processes every element of the array. Yes, it does. That's very true. I think it does that as well in Ruby. All right, so here's selects. So like if we wanted our array of names, right? Let's see, it might just be easier. Nope. All right. So in this case, I want to select a name. I can say, and this is an enumerator for Ruby, which is select. I am going to select foo, where name equals foo. But the important part here is to see that return, which is it actually adds this to an array. Okay, this is Ruby. All right, it probably does the same in JavaScript, but I cannot be sure of that. Detect, very similar. Do you see? Foo. However, it does not return it as a value in an array. It just returns the value that equals foo. Okay. And this, I think, does the opposite, which is reject, which is going to say, I don't want anything if it's equal to foo. Okay. Awesome. Kind of nifty stuff. All right, Yao, here you go. Thank you so much for that. Very important. Map is this, which is we're going to manipulate and return a whole new array, right? I think it's going to break though, because so let me do my names again because I deleted foo, so that's not going to work. It's going to throw an error on me. Oh, it might not. It might just go over. I can't remember. It might just yeah, it won't do anything. But now what I've done in map, you can see my returned array is no longer foo bar baz, but it's done what I've asked it to do, right? If the name equals foo, I'm going to downcase it. If it doesn't, everything else, I'm going to upcase it. All right. Okay, cool. This is kind of extra where you have like a for loops with range, which I know it can be used in many different ways. I don't know if we have time. I want to keep moving through. I want to go ahead and get to Big O. Do you guys have any questions over what we've gone over tonight? Excuse me, I'm a little sniffly from today. All right, you good? All right, awesome. And thanks to everyone who've been so helpful. All right, let's move on. Asymptotic analysis of an algo. All right, so what is this? All right, essentially, and what I like about this course that I took is very basic. It helps you kind of like see it from, in like layman's terms. It doesn't get too deep into the theory of it, but I do suggest there is a Stanford course on, I'm blanking right now, but it's called Divide and Conquer. And it really breaks out Big O notation. And I would definitely suggest to try that. I'd have to send that out to you guys after the class. But what this does is it gives us an analysis of the resources. What are the operations, the number of times we need to perform some operations, memory, how much memory is consumed by the algorithm, right? And then there's others like network transfer, compression ratios, disk usage. But most of the time we're really looking at the first two, especially like if you're wanting to look through a LeetCode, right? Or if you're doing a problem with an interview and they ask you like, what is the Big O notation, right? All right. So we're going to break this down a little more, and then maybe we can just use like the last 10 minutes. If we can get through this in 5 minutes, 4 minutes, the last 10 minutes, just open up for questions and maybe networking. All right, so big O notation, what is it, right? Is a common way to express the classification or cost of an algorithm. We use big O to represent the upper limit of the algo's cost and complexity. So if you looked on a graph of linear time, it's going up, right? And we're trying to determine what is the best way to go about operations in memory. Associated with a big O, a parentheses including a formula that uses the letter N as the size of the input. So the easiest way to really look at this is that the N is going to be the size of the input, right? So in this case, we're looking at an array. If this array was written all the way out, it would be 27, I think, or no, 25. Anyway, it's going to be 26, but minus or plus 1. So that length is going to be N. So say we want to go through and iterate and find the item where we find G, right? Going through this, we still have to go through, if we do ON, right? It means we're going through every index where N is the input size, okay? So we're going and we have to go through it regardless, even if we find G at 7, we still have to go through the entire input size, okay? All right, so let's look at some examples. And I really wanna focus on these because we're gonna use these throughout our data structure analysis course, right? Or our series, right? So on O1, function lookup time is not changed by the input size, okay? So here you can look at this and you can see that these are not changed, right? It doesn't matter how much, a lot of the time, hash map is known for O1 because we can find a key and we can return that value, just finding the key, right? So it's usually just O1 lookup time, right? Something important is to remember that it doesn't mean fast. It just means that the growth is not changed, right? The size of the array here, it's not going to change our cost, all right? ON. So ON is mostly looking through an array if we're not doing any divide and conquer, which we'll get to the next slide. So ON means that the amount of the array or the input size, like you can see here, is going to be our cost. So if we have an input size of 1, we have to look through it 1 time. If we have an input size in an array of 100, we have to look through it 100 times, etc. All right. Any questions about that? All right, cool. So O1 just means lookup time is 1-to-1. It never changes with the input size. ON means input size is dependent upon N is the length of the array. All right. Cool, cool, cool. Let me stop. All right. O log N scales logarithmically with the input size, working by dividing a large problem into smaller chunks. The cost does not increase at the same rate as the input size, okay? So what does that mean? If we were to look at an array of where we have aardvark, we have all the animals on the planet in an array as strings. And we're searching through aardvark to zebra, and we're trying to find giraffe, which would be somewhere in here, right? We want to find it here. What O log N means is if we were to know and divide the algorithm to know that an ocelot is alphabetically greater, so it's going to have a greater index, but elephant is less, we can narrow down our search, right? Between elephant and ocelot, right? And then that actually cuts our cost down. because we're not looking through the entire input. So say we have 750 animals, we're only going to look at a small portion of them based on our algorithm. Okay. So the input size doesn't change. It does not increase at the same rate. So where here it's 1 and 1, here it's going to be 3 and 6. Okay. Yes. Thank you, Larry. Absolutely. 100%. Well, I hope that came across because A is here and Z is here. But yes, the important thing that Larry says is that there is an assumption that this is a sorted array. 100%. It would not work if it wasn't sorted. Good call, Larry. All right. Any questions about this? Where are these drawings? All right. ON up to, or ON squared, function that exhibits quadratic growth relative to the input size. An example being a nested loop. So for every time that we do the first loop, we have to do the inner loop, right? ON squared, okay? ONM, function that has two inputs that contribute to growth, all right? A lot of times you'll see a matrix, which is a form, and it's a double array, which is OMN. It can be ON squared if the values are equal. Like if both inputs are the same, it can be ON squared because you have to go through each one twice. But if they are not, then it can be OMN or ONM. All right. That's it. We made it. All right. So I really want to open up. You're welcome to unmute whatever you want. If you want to maybe ask any questions, let's go ahead and open up for a QA. Thoughts? I can't really see. Hold on, I'm trying to. You can just unmute if you want, if you have any questions about today's. Review.
Hi, not exactly about today, but if this is going to be an ongoing session every Monday, or it's just a one-time thing.
I haven't scheduled. Sorry, I knew that might come up. So I actually haven't scheduled for the next class. I'm thinking probably, I was thinking maybe linked list. I don't know. I might do hash map just because I think it's like the next right thing to do. I'm still not sure about that.
Yeah,
But
hash map is a good one because I had I had an interview and they did cover hash map and I went blank. I had no idea how to.
yeah, these are super important. That's why we're doing this. It's helping me too. So hash map is I think might be the natural progression, honestly. But linked lists are super awesome. So I don't really want to give up on those. We'll do those later, I think, but I might just do hash map next. So yeah, I don't know. I need to look. It's not necessarily on Monday, but I think it might be. I think what I've decided is 2 weeks from now. So if you want to join, I will put it up in the meetup. Are there any questions about, I will make sure I put it up in the Slack community and I broadcast it. But I'm thinking 2 weeks from now, which might be Thanksgiving. So it might have to be after Thanksgiving, but I will make sure that it is, I just want to give proper time because, I want to make sure people know about it and they can join and everything like that. Otherwise, sometimes it gets a little frustrating. If there's anything else, our trees and graphs. Yeah, I did a class on trees, which we did DSF and BSF, and it was super successful. And I really would like to go over trees. It's not a part of his course, but what we're going to do is binary search trees. Christine, I don't know if we'll do graphs. I need to think about it. But yeah, I mean, why not? I think maybe we should. Graphs would probably be helpful. I mean, they're super important. So yeah, we could do graphs. I'm going to stop recording.